Ear Anatomy and the Steps of Hearing by Kaitlyn Gonzalez. Disclaimer: before we begin, I would like to say that all experiments were conducted ethically. Participation was voluntary. Participants were provided with informed consent. Researchers maintained participant confidentiality, and no mothers were harmed in the making of this video.
Mom! So loud, you scared me!
I'm sorry. Why was my mother able to hear my voice? Why was she able to interpret the loudness and pitch of my voice? How was she able to distinguish my voice from that of the telenovela that she was watching? These are all questions that understanding ear anatomy and physiology will help solve. Anatomy surrounds the structures or parts of the body, whilst physiology hones in on how those parts work together for a specific focus. Let's begin with a closer look at our ear's anatomy, focusing on the structures of our ear. To begin, let's start off with the outer ear. The visible part of the ear and ear canal, typically referred to as one's cartilage, is known as the pinna. Moving inwards, sound waves travel into the ear through the oval canal, reaching the eardrum, and three tiny bones known as the ossicles. The ossicle bones are called the malleus, incus, and stapes. The seashell-shaped object is known as the cochlea, which is below the semicircular canals, and the auditory nerve. This nerve will transmit information into the auditory cortex of the temporal lobe in the brain. Before we talk about hearing physiology, let's briefly go over sound waves. A sound wave is a wave of compression in which a sound is disseminated into an elastic medium such as air. Each sound produced has a different type of sound wave. The frequency of a sound wave determines its pitch, whilst its amplitude or height will determine how loud or quiet the sound is. Thinking back to our beginning questions, the interpretation of different sound waves allows for my mom to differentiate between the television and my loud voice. Pitch. There are two main theories that determine how we are able to differentiate between different frequencies of sound: place theory and frequency theory. Place theory suggests that we hear different sounds because different places are triggered within our cochlear's basilar membrane. However, this theory only explains high-pitched sounds because when conducting experiments, low-pitched noises were not easily located in the cochlea. On the other hand, frequency theory states that the rate of nerve impulses traveling up the auditory nerve match the frequency of a tone. However, this theory only explains lower-pitched tones, as an individual neuron cannot fire faster than 1,000 times per second, but we can sense frequencies above that. These two theories work together to help us understand perceptions of pitch.
Created using Powtoon.